Okay, so the lesson for today is multiplying polynomials. It's kind of a review of what we've done before, but we're going to expand this a little bit because we're getting into the quadratics unit. So when you multiply polynomials, just make sure that you distribute the outside term to every term inside the parentheses. Don't forget about the rules for exponents. Watch your signs and make sure that your answer is always completely simplified. So in this first particular problem, you've got 5n that has to be distributed to everything inside the parentheses. Well, 5 times 7 is 35, n times n is n squared. And now we're going to be doing 5n times negative 2, which is negative 10n. This is going to be your final answer because n squareds and n's are not like terms. They cannot get simplified any further. With the fractions, don't get all thrown off by that. It's kind of like we talked about in terms of the do math. Okay, so you're looking to do 1/4 of 8. Well, 1/4 of 8 is like 8 divided by 4, which is just 2. And then we've got x times x squared, or 2x cubed. And then as you keep moving along, we need to do 1/4 of 12, which is just 12 divided by 4. It's positive, so that becomes positive 3. X times x, x to the second. 1/4 of 24 is 6. It's minus 6. And x times no other variable is just x. X cubes, x squareds, and x's do not simplify any further. They're not like terms. And there's your answer. Gets a little bit longer here, and you need to be very careful. Negative 4 times 5 is negative 20. X squared times x squared is x to the fourth. Y squared times y is y cubed. Go to your second distribution. Negative 4 times negative 3 is positive 12. X squared times x, x cubed. Y squared times y, y cubed. One last time, negative 4 times positive 4 is negative 16. X squared times x, x cubed. Y squared times y squared, y to the fourth. In terms of your like terms, do you have any? Well, x4, y3s are nowhere else. This is x3, y3. This is x3, y4. So there are no like terms. This is your final answer. Okay. So now we're dealing with 2 times the quantity 4x minus 1 plus 10. Understanding here that what's happening is your distributive property really just starts and stops there. The plus 10 is something that's being done towards the end. So 2 times 4x, 8x, 2 times minus 1, minus 2. Remember, this plus 10 has got nothing to do with the distributive property. But in the end, you do have some like terms here. So the final answer becomes 8x, negative 2 plus 10, is plus 8. And now you're finished. This next problem, here's a distributive property piece, and here's a distributive property piece. You've got to keep them separate. So 3x times 2x, 6x squared, 3x times negative 4, negative 12x, negative 6x times 5x, negative 30x squared, negative 6x plus 2, or multiplied by, I should say, by 2 is negative 12x. So as we've multiplied through here, we do in fact have some like terms. We've got x squareds here. We've got x squareds here. Notice how I've circled that minus 30x squared. So 6x squared minus 30x squared is negative 24 of the x squareds. You also have like terms in with the x's, right? Here's a negative 12x. Here's a second negative 12x. They're not opposites. They're just the same value. So negative 12x plus another negative 12x is negative 24x. There's your final answer. Okay, so these were all basically monomials outside the parentheses. Now we're going to actually have multiplying by two polynomials, or two different polynomials. So you're going to use the distributive property. Some of you might want to use the box method to multiply everything in the first parentheses times everything in the second parentheses, and you simplify by combining like terms. Some people know this as FOIL. However you want to call it is fine, but just realize that you're going to be multiplying a by times a by. Two things times two things means you should get four things. So m times m is m squared. M times 4 is positive 4m. Now I still need to go back to the negative 3. What I'm going to actually do is I'm going to draw the arrow on the underneath, and I happen to also indent one over to the right. So negative 3 times m is negative 3m, and my like terms are lined up quite nicely. Negative 3 times 4 is negative 12. So now that my like terms are all lined up, I've got m squared plus 1m. The 1 is not necessary to include. I just like to put it there, minus 12. And there's your final answer. Remember, sometimes we've done this by the box method. I'm going to show you that too. I prefer to do the distribution method, but some of you guys might want to do box method. It's your choice. The box method would have a 5x and a negative 6 here, and a 5x and a positive 6 here. So now as you go through and multiply, you would say, well, 5x times 5x, 25x squared, negative 6 times 5x, negative 30x, 5x times positive 6, positive 30x, and then negative 6 times positive 6, negative 36. Your like terms come up here on the corner, but notice that they're opposites, so they will in fact cancel each other out. Negative 30x plus 30x is just 0, so your final answer is 25x squared minus 36. So you need to decide whether you want to do the box method or the distributive method. From here on out, I'm just doing the distributive method, but again, you are more than welcome to do the box method if that's your preference. 7x plus 4 quantity squared. This was something that was on the midterm exam, and we always said that if you've got the quantity squared, you really have two parentheses of 7x plus 4. So it's 7x plus 4 twice. And now as you start following the distributive property, 7x times 7x, 49x squared. 7x times positive 4, positive 28x. Indent 1 over underneath. 4 times 7x is another positive 28x. 4 times 4 is positive 16. So your final answer becomes 49x squared plus 56x's plus 16. And this, again, could have been done by the box method, just not my method, not my preference. This next one, 2x minus 3y quantity squared means 2x minus 3y twice. And then again, distributive property, 2x, 2x, 4x squared. 2x negative 3y, negative 6xy. Indent underneath. Negative 3y times 2x, negative 6yx, negative 3y times negative 3y, positive 9y squared. Understand that these guys are in fact like terms. I wrote the letters in a different order, but you should remember from the beginning of the year that the commutative property allows you to switch the order. We tend to kind of write things more in alphabetical order. So 4x squared is what it is. Negative 6xy, negative 6xy again, negative 12xy's plus 9y squared. Final answer. Okay. Now we get into, maybe not, here we go, number 10. Now we get into a binomial times a trinomial. Two things by three things. I'm still going to use the distributive method, and I'm still going to be doing my indentings. I'm going to color code this one though. 2x times x squared, 2x cubed. 2x times 3x, 6x squared. 2x times negative 8 becomes negative 16x. If I start going with the next one, 3 times x squared becomes positive 3x squared. 3 times 3x becomes positive 9x. 3 times negative 8 becomes negative 24. Again, notice by doing the indenting, everything gets lined up in terms of its like terms. So the final answer becomes 2x cubed, 9x squared, negative 16x plus 9x, negative 7x minus 24. Final answer. Keep hitting the wrong button. So now here's the biggie. It's a 3 by 3. So again, I'm just going to follow the distributive property. You can box it. I prefer the distributive property. X squared times 3x squared, 3x4. x squared times negative 4x cubed. X squared times 6, 6x squared. I'm going to switch colors, I'm going to indent, and I'm going to use the 5x for everything. 5x, positive 3x squared, positive 15x cubed. 5x, negative 4x, negative 20x squared. 5x, positive 6, 30x. One more piece with the negative 2. Negative 2 times 3x squared, negative 6x squared. Negative 2, negative 4x, positive 8x, negative 2, positive 6, negative 12. Again, when you do the distributive property, assuming you do the indenting, every like term gets lined up quite nicely for you. Final answer, x4s, just 3 of them. If I add my x cubes, negative 4 plus 15 is positive 11 of the x cubes. When I add up my x squareds, notice that positive 6 and negative 6 will cancel each other out. So there's just negative 20x squareds left. When I look at my 30 plus my 8, I get positive 38x. Final answer, minus 12. Okay, so we got a couple of word problems and then we are good to go. Let's see. For each of the following, make sure that you define the variable. Make sure you set up an algebraic expression, not an equation. We're not solving anything, just an expression, and that you simplify. So you are designing a rectangular skateboard park. You decide that the length of the park should be 5 feet less than 3 times the width. Write a polynomial expression that represents the area. Okay, so we need to find the area. Area we know is length times width. We know least about the width. I'm going to actually draw a picture. Here's how I'm going to define my variable. I don't know anything about the width, but I know that the length happens to be 5 feet less than 3 times the width. Okay, so define the variable by the picture, but I'm also going to come on this side and say, well, my width is what my x is, and then my 3x minus 5 is what my length is. So when I actually do the area, I'm going to say, well, the area then is going to be length times width. I'm actually going to set it up more as width times length. It doesn't really matter, but I've got a monomial multiplied by a binomial. And if I simplify this expression, I know that the area is going to be 3x squared minus 5x. And that's all it's asking you to do, is to write a polynomial expression that represents the area of this park. Let's take a look at the last word problem. The length of a rectangle is 3 centimeters greater than the width. If each dimension is increased by 2 centimeters, write the expression that represents the new area. So we're dealing with area again, area being length times width. We happen to have 2 rectangles. One of the rectangles we'll talk about over here. We don't know anything about the width. We're going to call that x. The length is 3 centimeters greater, so this becomes x plus 3. Well, it says that each dimension is increased by 2, which means I'm going to have a brand new rectangle. And if I take my original width, I'm going to increase that dimension by 2. If I take my original length, I'm going to increase that dimension by 2. So essentially what's happening here is we've got a brand new rectangle whose length becomes, combined like terms, x plus 5. And whose width becomes x plus 2. If I want to write that expression for the area, I need to multiply those 2 binomials. So what happens here is I'm going to be multiplying x plus 2 times x plus 5, distributive property. It's going to give me x squared plus 5x, indent and go under, plus 2x plus 10. The expression for the new area, x squared plus 7x plus 10. Okay, so there you go, and you should be good for the homework. Here we go.